people, once again. So we are now starting with the Iupac naming. So the Iupac naming, basically Iupac stands for International Union of Pure and Applied Chemistry, and this union came up with these sets of rules to actually now name these molecules. That's why we call this nomenclature. Nomenclature, you could basically say that it is a set of rules to do stuff, right? So here in chemistry, it's a set of rules to name our compounds and whatever. So now we are having here these rules that you are going to be covering. So in this video, I'm not going to be doing any of the molecules, but I'm just going to show you the primary stuff that you need to know. You always need to know this by your head. You need to cram it if you have to cram it. There's no other way that we can make you understand, but you are supposed to know it, right? So now, number one, you will be having your number of carbons in your parent chain. So you'll be having your number of carbons in your parent chain, and then now versus the prefix. So every time you are going to have your alkanes, your alkenes, your alkynes, and your haloalkanes. This is gonna be the prefix if the number is 1. So if it is 1, you are going to have eth. If it's gonna be 2, it's gonna be 1 is meth and 2 is eth, and then 3 is prop, 4 is but, 5 is pent, 6 is hex, 7 is hept, and 8 is oct. But now that only works for what? Your alkanes, alkenes, alkynes, and haloalkanes. So when it comes to the rest of the homologous series, you're going to see that you have to put this an after that meth, eth, prop. So then it becomes methane, ethane, propane, butane, pentane, hexane, heptane, and octane. So be very careful. So for your alcohols, your aldehydes, your ketones, up until your esters, you will see that you need to put the an after that name. So now, let us move on to this now. So now we have this part whereby you're going to be having the number of substituents. So it's your number of substituents versus their prefix. So now, if you have 2 substituents, it's going to be di. If it's 3 substituents, it's going to be tri. If it's gonna be 4 substituents, it's tetra. And then your example, if you have 2 chlorines, you're gonna have what? Dichloro. If you have 3 methyls, it's gonna be trimethyl. If you have 4 bromines, it's gonna be tetrabromo. So now here's a note. Only, guys, only the first letter of the substituent matters for the alphabetical ordering. What do I mean? You're going to see that in Iupac naming, what we're going to do here, you're gonna have your substituents. Let's say your substituents just like this right here. So we have a chloro, we have a methyl, we have a bromo. So now, in front, before that chloro, your methyl and bromo, there is this tetra, there is this tri, there is this di over here. So now, this first letter of the di, your tri, your tetra, they do not matter when it comes to alphabetical ordering, because in Iupac naming, these substituents, you have to name them alphabetically. So now it means like when you do it like this, you have to start with your what? So we see that we have a methyl, a chloro, and a bromo. So now we have to start with the bromo. But before the bromo, there was what? There was a tetra. So it's tetra bromo. And then we have to follow with the what? We have to follow with the dichloro. So we have to follow with the dichloro. Then at the end of the day, we end with the trimethyl, right? So now, some students I've seen that they tend to confuse the first letter with these tetra, your di, and your tri. So guys, do not make that mistake, because now you have a di and then you're gonna say that, okay, this di is gonna, because now there's a di, now I have to change the ordering. No, only the first letter. So here we see we start with the B, then it's gonna be your C for the substituents, then it's an M. So please be very careful for that, people, I beg of you. And then now we go to the suffix now. So for your suffix, you're going to be having what? So the suffix depends basically on your type of homologous series so that you're having. So for your alkane, as you can see, I wrote it differently. It is in the name. The suffix is going to be ane. For your alkene, it's going to be ene. Your alkyne, it's yne. For your alcohol, it is going to be ol, it is in the name. Aldehyde, it is al. Ketone, one. Haloalkane, this is an alkane with a halogen, so it's still ane. And then now the story changes when it comes to your carboxylic acid. It's no longer now in the name, but then it's just going to be oic acid over there. And then we go to the ester. The ester tends to be a bit special, right? So now what happens with the ester is that you're gonna see an ester, it is made up of an alcohol and a carboxylic acid. So since the ester is made up of the alcohol and the carboxylic acid, from the alcohol name you are going to remove anol and you are going to replace it with yl. So here's an example. If you had your alcohol name as a methanol, basically you remove this anol and then you are going to replace with yl. Same goes for the carboxylic acid. So the carboxylic acid, you remove oic acid and you're going to replace with OH. Just like here we have methanoic acid, and here we are going to have what? Methanoate. Keep in mind again that this alcohol that makes this ester, it must be a primary alcohol. So that goes into when we are going to be going to reactions, but don't ever forget that when you are going to do your organic reactions, you have to have what? A primary alcohol to prepare an ester, because there are types of questions that can test you on that. So guys, these are basically the set of rules. So you can just go back to whatever we did, you pause the video and you actually write your notes down as we go to the next video, when we now explore how to actually name these molecules. So let us move, guys. Peace out.